a project. A project I've been working on, which is just a Twitter text analysis. And I'm going to be continuing to work on it. So this is not like a completely finished project. I finished the first part, but I definitely need more data to make it look really good. But I'll be talking through that. I'm going to do a little slide presentation, and then I'll show you my code after that. So this is just a little introduction about me. My name is Christina Roig. I go by Chrissy. I'm going to be finishing my Master's of Science in Data Science in December, specializing in AI through Northwestern. I'm kind of newer to programming. I just started my first class probably in 2018 and took a class at FGCU in 2019, and then started my master's sometime after that. Oh, right as COVID started, of course. Yeah, I studied completely different things before this. I did biology, chemistry, psychology in college, undergrad, originally from Chicago, and my other career is teaching dance and circus. So completely different. And also I pretty much live in a circus because I have 4 kids, 3 dogs, a cat, and a bearded dragon in my house right now. So pretty much crazy. And Keith. All right, so I'm just going to give you an overview of the project. So this I've worked on with a partner. My last quarter I had an NLP specific class. This quarter I have just an AI class. But I worked with my partner Shrija, and the 2 of us worked on that. So you're going to see stuff that the results that we got last quarter, and we're going to continue working through it until December, basically. But the goal of our project was to, number 1, see the change in Twitter usage across 3 years. So we downloaded data from 2019, 2020, and 2021 to see how people use it differently across the 3 years. And also we are going to cluster tweets and classify them by topics so we could kind of get a good idea of what topics people are talking about from year to year. So in this, we utilize both unsupervised and supervised learning, which, unsupervised learning means unlabeled data. So that's just the tweets coming in, and we attempt to cluster them, which I'll go over a little later. And then supervised, meaning we label the tweets as to what the topic is next to the tweet and cluster the rest based on that. But I'll show you more of that as I go through. The platform, it's all in Python. I mostly use Jupyter notebooks, and then I ran one part that was a little bit more heavy. I used the GPUs for Colab Pro because it was going to take forever. And then I used a Twitter developer API and the Tweepy, I call it Tweepy, it's probably Tweepy, but Tweepy library to pull the tweets. I did mention this, but I'm just got a Twitter academic API, which lets you get so many more tweets, but they don't let you use TweetPy, and so that one I have to use for. It's very interesting names, but yeah, so that'll be the next step after this. So as I mentioned before, the data I used, I took 1,500 tweets just basically because of the limits of the Twitter API, so it wasn't a ton that I could get. 1,500 tweets from May 1st of 2019, 2020, and 2021. We just picked a day so we could have them all from the same time of year, and we didn't want a day that would be overwhelmingly something else happening, so we didn't want to pick, a holiday or a day that, something big happened, and May 1st seemed to be a good day to use for that. We cleaned the tweets, so removing stop words like to, the, and, in, just unimportant words. We had to remove symbols, emoticons, links, numbers. I removed words that were less than 3 letters because like RT, retag, is, a retweet was in so many of the tweets I downloaded, so I had to kind of get that out of there since it didn't really add to the content of the tweet itself. I lemmatized words so that they could be more easily grouped. Like, if you had the word apple, apples, it just puts it all together so you could count how many of the words there were when you're doing a bag of words. Word Ninja, this was kind of cool. I had never heard of this before, but it separated the words. So when I had the issue of having a hashtag where somebody had like a bunch of words all together, Word Ninja separates it into separate words. So, you know, if you had like Sunday Fun Day or whatever, you know, it separates them in 2 words as opposed to having them all together. In the end, I ended up working mostly with just the nouns, and I'll show you why in a little bit, but that actually seemed to work the best. So went through each step and kind of looked at the results, and the nouns seemed to work the best for telling you what the content of the tweet would be. Okay. So this is one of the word clouds I made that was just cute. It was just pretty, but what I did is I took the most frequent words and I put them in a cloud, and then I applied a mask to make it a little bit more visually appealing. So it was in the shape of the Twitter bird. I had a couple different ones that I can show you within the code, but you can see in this one, and yeah, this is an example from 2021. The biggest words when I took everything out and just had the nouns left were words like people, year, today, world, work. Some of them were obviously very relevant to the time period. I think the 2021 had a lot of like COVID and death in there, but this one had, yeah, game, play, player. So, you know, a little bit general, but it was much more specified than when I just left it to all of the words. All right. So I'm going to talk about TF, IDF, and K-means, because this is how I started. Once it was all cleaned, this is how I started working with the data itself. So the TF, IDF is term frequency, inverse document frequency. So this is basically what it is you're looking at how frequent the words are in each document compared to across all of your documents. So for this, it would be in each tweet versus all of the tweets. Some words that were very weird would show up as more important just because they were so unique that it popped up as a important word. So that I'll show you in the code later. And then K-means clustering, that was a method that I used for supervised or unsupervised clustering. You can see the elbow method. This is just an image that I pulled because this one was much cleaner than my elbows. So I thought it'd be easier to show you this one, but you can kind of see that at 3 is where it bends. So for this set of data, if you saw this elbow, you would limit it to a K of 3, so 3 different topics, and then it would break it into 3 separate topics and cluster. And then you can look at the most common words in the 3 different clusters. So I mostly used 6 clusters in mine, but when I was using K-means, but there was a lot of overlap, so it wasn't super clean. This is visualizing topic clusters. This is just a pretty UMAP, and you can kind of see though the different topics a little bit clustered. If I had a lot more data, it should look a little bit more cohesive of clusters that don't run together, but this is with my 1,500 tweets. This is what I could get. And you can kind of see the clustering, you know, in certain areas where a little bit. But again, sometimes since Twitter is so, people can tweet about anything, it can be 8 topics in one tweet, and that's where you see all the little kind of gray dots of things just blending together. Okay, so the biggest problem we had is how to label the data if we wanted to actually have labeled data and put it into classifications. So we came up with 2 different methods to test. One was looking at the first hashtag that was listed within the tweet and taking that as the label. So, you know, if it was like hashtag vote, you know, that would be the label on it, would be vote. You know, any number of words could be in there, but just the first one we took and used that as the label. The problem with that was it would require people to use the same hashtags. So if somebody said vote and somebody else said voting, or some, you know, used vote 2020, whatever, you know, different numbers attached to it, those would all be separate classifications. So that was a little bit of an issue. Also, it would mean that people would have to be using the hashtag to indicate the subject matter of the tweet, which, it's okay.
So that doesn't work? the guy cannot get it on, so he would have to file something.
Yeah, it's a little bit small, sorry. But yeah, so yeah, basically the hashtags would mean that people would have to really use them well, and you're leaving it up to the public, and you'll see the results of that one. And then the method 2, I found a pre-existing a Kaggle data set that had news headlines, and it was, I think there were 200,000 news headlines, all Huffington Post from 2012 to 2018, but it was all labeled. So I could train a model using that and then apply that model to, ooh, yay, awesome. Perfect, now you can read it. You could use that model to run the tweets and then apply the same news headlines to the tweets themselves. So, and that is using the assumption that tweet subject matter coincides with news headline subject matter. So those were 2 big assumptions, but that was some methods that we tried out. The models, transformers I used. A transformer is a deep learning NLP model that utilizes attention, which is weighing different parts of the text, and just basically as we do when we read. When we read a sentence, you look for the most important words. That's what transformer models do. Specifically, BERT transformers, and more specifically, I used a Roberta transformer. So the BERT transformer is pre-trained by Google, so it's trained on text, which helps because it isn't just looking at the words, but it's looking at the content of the words, because it's been trained on how sentences are formed. And beyond that, Roberta is even trained further and optimized, so that is a really good model to use. And this is my results. Well, I just gave a little snippet of my results. So basically the hashtags were horrible. It maybe potentially would be a little bit better if I had more data, but they were really, really bad. So if you can see, what I put up here is what the original tweet was, the cleaned tweet after, I stripped everything away, what the news headline from the Kaggle data set would predict the topic to be, and then what the hashtag, using the model that ran based on the hashtags as the label, what it would predict the topic to be. So as you can see, it's really, the hashtag one was terrible. Like the first one is daily gun deaths. 16 people lost their lives to gun violence yesterday, including 2 students. UNC Charlotte, the number of people dying. And the headline prediction is crime, which, that's pretty accurate. And the hashtag prediction is the BBMAs, the Billboard Music Awards. So didn't work. Some of these other ones, though, some of them were kind of funny. But let's see, somebody talking about their grades. I needed 92 on my final today. The headline predicted it as education. The hashtag predicted it as BTS. So, nope, that didn't work. And basically I finished with me, machine learning, having to go through the math and linear algebra and calculus prerequisites. Kind of nope, but that's it. So I'm going to show you now my, let's see, how do I get back to other screen? I'm going to show you my code now, and I have a lot of it. Let's see if this is working. Huh. Doesn't look like that on my screen. Let me stop sharing and reshare again and see if it. Oh, that's working now. Okay, so I have, this one is my 2019. I had just a notebook for each of my, at the beginning, for each of my years that I took tweets from. So as you see, I started with the NLTK, which is what I used to clean the tweets. And if anybody has questions about some of this, you can let me know. But I ended up liking the lematizer more than different method, the stem. I see I had stem in there, but I like the lematizer better. It seemed to have more accurate ways of cleaning the words. Just a whole lot imported in there. This is just bringing in the data frame. So this is the data frame as it was brought in. The ID string, the just raw text, screen name, location, country, when it was created, and the first hashtag. As you see, there's a whole bunch of.
Question. So what are the general steps? You first collect the data, then you sanitize it.
Yes. Yeah. So first, you're going to pull the data, and I should have that in here somewhere. I believe I already saved the data on. I had already saved the data at this point, so I had a different. Let's see if I have it open.
You save the data in text format, database.
As a CSV file.
CSV file.
Yeah. So is this showing here? Yeah. I think this is where I had it pulled in eventually at first, but you had to get the Twitter API, and this is my new Spark one that I'm attempting to work through. But yeah, just you pull the data in, save it as a CSV file. Well, I saved it as a CSV file, and then brought it in to work with it. So at this point, then where I'm at this notebook, it had already been pulled in, and that's when I can start cleaning with it. So this is the data frame as I have it, just 1,500 rows. Let's see the data types there. I'm gonna go through, okay, so here I just split the text up, brought it to lowercase, tokenized it, and looked at the most frequent words. And obviously you can see this isn't gonna help you at all because it's the, a, RT, retweet, to, HTTPS, didn't tell you anything. So that's where I had to clean it further.
So when you look at the data, you have like the value general and then the number 46. What's 46 how does that data came up?
Where are you looking? 46?
It could give you one.
Oh, okay. Yeah, this is just the number of times. So within my 1,500 tweets, this is the number of times these words showed up out of all of that grouping of tweets. So the 2019 tweets that I pulled. So the word "the" showed up, 1,635 times. So like word frequency can tell you a lot about what people were talking about. Like the word performance showed up in here a lot. But a lot of these were just very general. So that's why I had to go and kind of clean it more. As I lemmatized it. I removed the stop words. In this line, I just did everything that wasn't alpha, just letters, I removed. I removed specific words that I thought didn't really help. So what's the question? How do you arrive at your stop words? Let's see the questions online. Is there a way to see what the chat is?
Yeah. I'm just curious how you came up with your list of stop words. It looks like some of them, like the ZK, that's just some garbage text that it pulled up.
Yeah. Well, the stop words is a list that it is pretty much it's in there already. It removes like VA. The list that I came up with, it was kind of trial and error. I could see these words coming up a lot, but they didn't help. They didn't help me with anything. They didn't help me come to any sort of conclusion about what the classification of the tweet would be. So I started removing some. Yeah, that ZK one, I have no idea, but that kept pulling the whole, because it was such a unique word. And as we talked about CFIDF before, it was a really unique word. So it showed up a lot and like pulled entire classification groups or clusterings over to that word. And it was just, when I Googled it, I think it was somebody's TikTok account. So it could have even been a typo, but I decided to kind of remove some of those words just so it didn't kind of ruin my data. But yeah, that list is just kind of trial and error. So when I removed that, I also removed any word that was less than 3 letters because again, I thought that didn't help at all with the subject matter if it's just a 2 or 1 letter word. And there was a lot of weirdness with things cut. If where it would just have like the letter R and a whole bunch of letter R's or RTs. So it was a lot easier. Somebody has a hand raised.
Yeah, I think NLTK has a package for stop words. So you can just use what they already pre-built in words. You can use remove all those common words with their pre-built stop words dictionary. So that would save you tons of time on some common stop words for sure.
Which what you're saying about removing the stop words?
Yeah, for those the, get, they, use, or may, and I, you, he, she, all those common words. I think NLTK has a package for stop words too. So you can just call their method instead of manually hard code it.
Yeah, right at the top. The NLTK has the stop words already as a library. So,
right, yeah.
Yeah.
That's great. I had never used NLTK, and having a built-in stop word dictionary, that saves a lot of time. I have to look at that.
Yeah, that really helps. The other stuff that obviously just like playing around with it and seeing that it didn't give me what I wanted, and so going back and changing it. But,
Question about the language.
Mhm.
Is there a parameter that Twitter API you know, speak in English or how do you know?
There, I believe you can pull it in just English because now I'm pulling more, or going to be pulling more data for now that I have the academic API, and I think you can set it to English only. I'm not sure if I had set this to English only because I think I saw a couple show up with non-English words within it, but yeah, you can set it to English only. All right, so I think we already went past this, or did we not? Let's see where I left off. Oh, okay, yeah, so we did the word frequent, the most common word. So now as it's clean, you have like bar, BBMA, the Billboard Music Awards, year, like, artist. So you can see one of the hot topics that everybody was talking about is the music awards, as you can see with the words like artist, people, year, tonight, performance. So we realized that that was probably one of the things we're trying to avoid is, getting away from there being a big event, but once I get more data, we'll get away from that. Yeah. Is there a raised hand again? I don't know why it's not showing up on mine. Okay. So from there, I did the word cloud, as I showed you guys before. It was kind of fun to use the mask. That was kind of a cool little thing that I found. But I just found pictures of Twitter symbols and then applied that to the word cloud so it would show up the way I wanted it to look with the right colors. This is a little sparse. The professor had it was really didn't want it too wordy, so I kind of took some out. But you can adjust how many words are in there, how big they are, over here with the font size, maximum words, background color, etc. So I just kind of played around with different ways of showing that. This one, I obviously have a little bit smaller text that you can't really read, but you can see the big topics, and I think that is what's most important. And one more. This one wasn't as good, but this I just took the actual Twitter symbol and kind of plugged it in. Okay, so next, let's see. So here's where, this is the Word Ninja. I just import Word Ninja, and that cleaned, like I said, when there was a hashtag and a series of words all stuck together, Word Ninja was really good at just cutting them apart into single words. So that's what that is. Here I have a whole bunch of splitting the words, removing RT, removing HTTPS, removing everything that's not alphanumeric. And in the end, this last one is noun. I just took away everything that wasn't a noun. So I kind of played around with this and hashed out certain lines and saw what happened. And removing everything but the noun was, I think, really helpful in getting better results for this. Let's see, how much do I need to show with all this?
What do you one hot encoding for there?
Well, let's see. That was for, where did I use that later? Because I used that initially, and then I might have ended up not using it. But I went into the, let's see, did I end up using it? I'm not sure I ended up actually using that, but I have to see for sure. I changed my code so many times.
Sorry, I was just curious. Sorry about that.
That's okay. I just don't remember because I had like several notebooks going at the same time and changed it all back and forth. I have next, the TF-IDF. So this is what we talked about earlier, the values. This is pretty sparse. You can't really see any of the values in here because it's, basically there'd be a number applied to these different words. And then on the, you have it labeled with people's usernames or their screen names and what words they use, and it's just a huge matrix that was used then to kind of skip through some of this. I want to get to the BERT stuff. So then that was used for the k-means clustering. So this is where I told you my elbow didn't look that great. That's why I showed you the other one before. This one, every time I ran it, it kind of curved a little bit differently. But for the most part, it seemed like there was a good bend around 6. So I ended up using 6 for the K value. And that clustered my words into 6 different clusters. So as you can see here, it took like the words that were chosen based on the TF-IDF, the most important words for each cluster, and it told you what the titles were. So the words that were most important. So you could kind of manually label these clusters if you just yourself read through it, and you can tell this one has a lot of like the Billboard Music Awards, Halsey Performance. You could tell that cluster 0 is most likely just talking about the Billboard Music Awards. Some of them were really hard to discern what they were talking about. Like cluster 3 again is the Music Awards. Cluster 4 has some music awards, Katy Perry, I'm assuming. But there were some that I had to, a word would show up and I'd have to just go back and see where it showed up in the tweets and look at the actual tweet to figure out what did this word even mean in the context, because just a name would show up as in a cluster. So that was where I was doing a lot of the back and forth. This is where I got that ZK, whatever it was, showed up as a cluster. And it was like, I had to go find where it was in all my tweets and what context it was used. And I just decided to remove it. So I kind of started like putting through like, what would I title the clusters? This was just kind of like preliminary. I didn't get all the way through that because then I decided to use something else. But this was another of the elbows. So this one again, I kind of settled around 6 for the K, the number of clusters. And these did not turn out that great. Again, because of the overlap in topic and probably not having a ton of data. But as you can see, the subject matter, like in this T-SNE cluster plot, it's overwhelmingly this one like yellowish green color. And then there's like a little bundle of this green here, and just you didn't see clear clusterings in this. And this is something that I would hope, if I had more data, would look a little bit cleaner. But then again, with it just being Twitter, it might never look really clean just because there's so much overlap in what people talk about. But that is going to be my next project, is seeing if I just pull in like a million tweets, what it looks like.
Did you ever consider getting hold of creating your own data set where it can see if it would, you can tweak the data so that then you can see how the results came out better?
So like a dummy data set of tweets specifically, or just any data set?
Don't you use that, just come up with data sets of data
Mhm.
where you could have created it, where you do have certain slants in the data, just for the point of research.
Yeah,
It seems
yeah.
like the problem is that you could mass produce it
Yeah,
without the restrictions of the developer APIs, where you're only allowed 1,500.
yeah. Well, now I got the academic one, so I should be allowed much more, and that's where I'm going to start with that. But yeah, that could be another step too, is just look at.
Because there's data generator tools out there. I don't know on Python. I would
Mhm.
assume there is a Python. But
Oh yeah,
and
yeah.
other tools like C# or other Java and everything, data generation tools.
Yeah, well, the tweet generation is something that I kind of want to play around with next. With the if anybody's played around with GPT-2 or GPT-3, that's super awesome. I'm gonna try to be playing around with that also, but you can generate tweets on your own after feeding it a model. But that is fun. If you haven't looked into GPT-3, it's really awesome. They even have like image generation from text. So you can type in text and it'll generate an image based on that doesn't exist yet. So it's really cool. But they have tweet generators as well.
For the PCA cluster, where you try to do other feature engineering with the results of that, or something else?
I was just trying to visualize if it was clustering at all, and it was not looking good. I messed with the numbers a lot, and it just was not looking very clean, no matter how I looked at it. But I did get the a UMAP to look okay at the bottom, but I used BERT for that, so that one looked a little better. Everything I used the transformers on, but these just not so great. So let's see if I can. Okay, so here's where I started with doing supervised learning. So these are the first hashtags. So as you can see, there's nothing really. One thing you'll notice is BBMAs is in there a lot, and researching that, there are certain labels that are used a lot just because it's advertised. So there were a lot of ads saying tweet whatever to BBMAs, and that's why that one was used so heavily. Whereas other ones like first home buyers, criminal, champion league, that none of this really tells you as much. And it's not one that people across the board would use, so it wouldn't be a great label. But it was an experiment that we ran through. This just tells you the distribution of the hashtags. So BBMAs was used 84 times, BTS was used 19 times, bar was used 5 times. So really uneven in how it was distributed. Obviously, immune was once, Prudential once, NASCAR once. So yeah, these were really specific terms, not general. So that is why it didn't work too well. But it was, there's ways to probably mess with this a little bit more and make it a little bit better. But yeah, so let's see. This is the ones that were labeled. So there were only, out of the 1,500 tweets, there were only 248 that had a first hashtag or any hashtag. So this is, I put the label on it. And so just the clean text and the label. Here is where I have the transformer model. So I used the Roberta transformer. I did not use the weights, so those are hashtag. And the results, save that. Yeah, you can see like right here, basically everything was labeled with the 9 or 1. So it's basically all getting 1 of 2 labels. And when I went through and looked, it labeled absolutely every tweet with either BDMAs or BTS. So you can see here, that's where it ended up. And partly too, because I trained the model on just that small group of 248, I think it was, labeled tweets. So and then tried to apply that small training set to a huge test set, which did not work too well. But that is that experiment. You can see where it all shows up, BTS and BBMAs for everything. So then I went to my news headline data set, and that one I ran in Colab. So I have another tab open here, but this is the Colab notebook, and it shows you, these are the different labels that I use. So crime, entertainment, world news, impact, politics, weird news, voices. Some of these I tweaked a little bit and probably could tweak further. There was like overlap, like one was science and tech and then one was tech. So yeah, there's, oh yeah, corgi mode. I have to set it to corgi mode. I love dogs. So there's always dogs walking across the screen. What's that? Yeah, you just watch the dogs when it runs. But like for this one, then we ran this model since it was 200,000 labeled, and I tried to balance the data set too, so it was pretty even. It was a little more even within these groups. What did I have? 26? Yeah, 26 classifications. So it was a little bit more even, and you know, like the sample, we put in the words "man bites dog," and it showed up as weird news. So you know, it was kind of working when we were testing it out. So I saved this model and went back over to Jupyter. And that is the wrong tab. That's what happens when I have a million tabs open at all times. Okay, so then I took the tweets and I put them into those news headline categories. So this I showed you a little bit before. It shows the original tweet, the clean tweet, the headline prediction based on that Kaggle data set, and then the hashtag predicted based on, or the label predicted based on the hashtag that was predicted for each one. So the headline prediction worked out pretty well when I looked. The one thing I noticed is that a whole bunch of them ended up in comedy. And I don't know necessarily, I'd have to go through and read all 319 tweets to see exactly, but I didn't know if that was kind of more of a catch-all category or if it was more that people generally tweet in funny tweets. So it just all fell into that category. But yeah, a lot fell into the comedy. There's a miscellaneous. There were only 6 that showed up in miscellaneous. So it wasn't very evenly distributed, but when I looked at individual tweets, it seemed to be pretty accurate. And that's all using the Roberta, the transformer. So let's see, from there, yeah, these visualizations were not showing up today. I have to rerun everything to get these ones to show, but skipping past that, yeah, some of them were not so great. And I don't know exactly where the, like here, this one example, baby broccoli, they're eating baby broccoli, but it comes up as parenting. So, you know, weird ones that kind of don't really fit, kind of, those were some of the mistakes in there that you can see. Yeah, homecoming season, we had prom shows up as parenting too. So.
We're making it figure at the threshold or what they will apply to the past, depending on, I assume that baby is very common in the parenting category, and there's like a threshold set and then to apply the label.
Yeah, I kind of wonder if you could like apply weights to it or something to get it to, and that was all just based on that model, the Roberta model with the that Kaggle data set. So it was already labeled, so it was all based on Huffington Post news headlines. So you kind of wonder maybe if you tried a different news headline data set, which I just found another one that might actually work in comparison. That's going to be something I'm working on the next couple of weeks. But kind of comparing different news headline data sets to one another and see if it kind of gets rid of those problems.
So just a dumb question, from the non-Python person in the room. So you're using the MLTK library, basically, is that what it is? That has all the, what are you using to do the crunching the models?
The models, that
Or
was,
analyzing the models that goes out?
yeah, the NLTK I just use for cleaning mostly.
That's what I mean, so that included just the like text processing or something?
Yeah, that was
What's
just
the
a,
library that does the crunching that you do?
so that would be all of this here, the BERT, the sentence transformer. Well, that one is for the lower one, but it's the Roberta transformers. So that is it's a language processing tool that was trained on Wikipedia and I can't remember what book corpus I think it's called, and they trained millions and millions of words into this model. So it,
But there's documentation on that out there, right?
on the transformer,
Yeah.
yeah, there's a lot. Actually, if you wanted to do more with transformers, Hugging Face is the website, and they have a lot of information about different transformer models. So I kind of used that to help me. And it's literally Hugging Face, like the emoji. So that's easy to remember. Yeah, but this is all Roberta. And the cool thing about the BERT, the transformer models, is I felt like it required less cleaning because it understood the context of the language more than some other models I've worked with before. Let's see if I can get through. Okay, so that is that. Some of these visualizations, so this here was not showing up today, and it wasn't really helpful. It was kind of just copies of what I had above, basically, but I was playing a little bit with BERT Topic, which is a transformer model that basically does the same thing as what, like, well, similar to what the K-means did above. So it clustered them, and there were various visualizations, but it was not showing up, and when I tried to rerun it, I'd have to rerun the whole thing. So I'm just going to leave that alone for now, so it doesn't all disappear. But I did get topics for class. Oh yeah, so this is like common words and frequency and the different classifications. And this is all, BERT Topic is really easy. It's just plug it in and it does it for you, basically. Sentence, okay, so then the sentence transformer is where I did the UMAP. This one I had to mess with a lot to make it look like anything, and I'm hoping, again, once I get more data, I've seen some really cool pictures of these UMAP clustering, where it really is just clear clusters in different colors in different areas. But this one, you can kind of see, I was adjusting, it used nearest neighbors, basically. What is it? Yeah. So using like 80 of the nearest neighbors to cluster for these, which is just most similar tweets clustered together. So I thought this one worked better than the TC and the PCA, but it gave me more freedom to kind of adjust it until it started to look like something, whereas the other ones were just kind of, I probably could adjust them more, but this one was easier and it looked better in the end. So I think that is the end of it. I do have, you can kind of see the different years. So this would be the 2020 year. And that was just kind of one of our analysis, is looking through the 3 different years of what people were talking about in 2019, 2020, and 2021. We're going to try to expand this to more years and like more months, not just May 1st, so that I can get a more accurate look of what topics people are talking about over time. think that's kind of useful to see. As you could, yeah, COVID was really big in 2020, so that's one of the big words in work. But it would be helpful to know, do people use Twitter mostly for just personal use or tweeting news, or, you know, and over time, does that change? Is, you know, if you could get a really good, accurate model, I know the parenting one was a little weird, but, you know, looking at each year, are the number of people who are talking about parenting topics going up or down? Are people who are talking about science and technology going up and down year for year? So that was kind of something interesting that we were trying to look at. But yeah, so this is the 2020 and 2021. Let's go back up. And again, you know, the clusters, same thing with this one. Is some of them are easy to tell, the clusters, and I like this one's the chill games. But you can tell this one, you know, COVID related, death, complications, comorbidities. So yeah, that is where the project is right now, and I'm hoping to just add a lot more to it. But does anybody have questions about this? Or
Yeah, I think that the images are really compelling, and I like the mask and everything. Are you trying to come up with like a word, like a sentence about how things are shifting year to year, or just like the artwork is different year to year?
yeah, I think it could be useful. I mean, probably on a bigger level, it could be useful even to businesses to know how do people use Twitter, and how does that change over time? And are people, you know, using it to tweet about, you know, science and technology? And if they are, then maybe it would be a useful platform for people who want to talk about science and technology. If they're not, you know, maybe it's not the most useful platform for that. So I think it could be useful in that way. This was mostly just to kind of easily visualize what people were talking about on May 1st. Was this one 2020? Yeah, on May 1st, 2020. In the first 1,500 tweets of the day, like, these are the words that people are mostly talking about. So people and time and COVID, obviously, were the biggest, really big ones. Yeah, I think it's just a kind of useful analysis overall.
Yeah.
Yeah. Any more questions?
There's one in the chat.
Okay. My chats are not showing up for some reason.
I think it says, do you have to clean up emojis in foreign languages from the tweets?
Yeah, and I'm trying to see where I did that, but I removed everything that wasn't alphanumeric, or alpha, then I took off numbers too, because even though there was, you know, COVID-19 and stuff like that, I took off numbers. They didn't really feel it was that useful. Let's see if I could find where I cleaned that. Yeah, right here, word for word in text one, if word is alpha. So that one basically only took the words and not numbers. It got rid of emojis, all of that. What I guess that kind of made me think of something interesting would be to find a way to translate. I guess you have to use a CNN though, to translate the emoji into a word that could be useful within the text of the actual document, because people use emojis in place of words. So that would kind of actually be an interesting thing to look at. But yeah, I just removed it. So
There's two people that had to do it for work once, who were doing with the compliance these days for them employees to see if they were distributing non-public information. Primarily.
Mhm.
And there were a few sources, but I guess tricky when they start using multiple emojis.
Oh,
When
yeah.
you combine them, it changes the meaning sometimes. So
Right.
it gets pretty tricky when they're like, we have
What did you use to?
I can share it later, but yeah, there's a few websites that have good labels for all the basic emojis. But then once you start combining them, it's really tricky.
Okay, yeah, that seems like that'd be difficult. I thought I read one research study where they did use a CNN on emojis, but yeah, I don't know if that would, I don't know how that would work with the text and the emojis all together. I guess you'd have to kind of separate them out and run them separately, maybe. Yeah. Any other questions? Well, this is what I'm going to be working on for the next few months until I'm done. So hopefully I'll have some more interesting stuff to share at some point that takes us further. But yeah. If anybody has questions about like what libraries I use and wants me to send them copies of anything, probably have way more than I actually used up here. But I can send this to anybody who needs it. All right, thank you.
Before we wrap it up, we have our little script for the raffle of the JetBrains. So I'll share my screen very quick. Actually, right here. Okay. I got everybody from the virtual part and from here in person, I hope. Oh, wait, I forgot you have to type yes completely. Just a second. Okay. James. I'll give it to you afterwards. I'll stop sharing now. Okay, I guess we're gonna wrap it up. Yeah, we usually hang out for the ones that are here for the first time in downtown. We usually go to the courtyard that is behind Downtown Pizza. There's plenty of food options and drinks and whatever, and it's outdoors too, which is good. So thank you everyone, and feel free to hang out for a little bit. And for the ones online, thank you very much for joining. Thank you guys.